Simple harmonic motion is a particular type of rectilinear motion. It arises when we consider the motion of a particle whose acceleration points toward a fixed point O and is proportional to the distance of the particle from O. Hence, the acceleration increases as the distance from the fixed point increases. As the particle moves away from the fixed point O, since the acceleration is pointing towards O, the particle will slow down and eventually stop at Q before returning to O. It will keep going and then again slow down as it reaches P before stopping at P and returning to O once more. Therefore, the particle will move between two fixed points, which is P and Q.
So for simple harmonic motions, there are some specific terms that normally question will ask you or you might need to know before you can derive an equation. So first we have amplitude. Amplitude is the value of x oscillates between negative a and a, which is two endpoints of a line. So to find it, you have minus a and negative a divided by 2. Next, we also have mean positions, which is considered as periodic of motions and equilibrium positions. It's basically about the centers of motions, and you need to find it by adding a and negative a divided by 2. Next, we have period. Period is the time taken for particles to perform a complete cycle, and to find it, divide 2 pi with k. So for object displacements, if the object starts from equilibrium position, which is the center, we use the equation of x equals to a sine kt. But if the object starts from an amplitude position, which is the two ends of a line, we use the equation of x equals to a cos kt. But if neither, means any point beside the equilibrium positions and amplitude positions, we can use these three formulas above here. So, when object stops and turns around, acceleration will become maximum and velocity equals to 0. Acceleration equation can derive into 4, which is the 4 equation above.
The equation for the rate of motion, which is the period, is big T equals to 2 pi over k. T is the time needed to complete one oscillation and it's known as the period, and k is the angular frequency. The constant delta 1, which is the phase angle, decides the position of the object when time begins, where t equals to 0. As you know, the second derivative of displacement is the acceleration, and to solve acceleration, the equation needed is v squared equals to k squared, open bracket big A squared minus x squared, close bracket. Since displacement is big A sine kt plus delta 1, maximum displacement equals to modulus A and minimum displacement equals to negative modulus A. For velocity is big A k cos kt plus delta 1 and maximum velocity is modulus AK. Minimum velocity is negative modulus. Acceleration's equation is negative big A k squared sine kt plus delta 1, where maximum acceleration is modulus big A k squared and minimum acceleration is negative modulus big A k squared.
As with all SHN questions, we will know that the format of the formula is displacement equals to A cos open bracket kt close bracket plus c. And then now we need to find the variables A, K, and C. To get A, the amplitude, we will need the maximum and minimum displacement. Maximum displacement is 60 meters, minimum displacement is 48 meters. So our amplitude A is basically 60 meters minus 48 meters divided by 2, and thus we get the magnitude of the amplitude of 6 meters. One thing to note, however, the question, we take 7 am to be the starting point, and thus the equation starts from the lowest part of the graph, which is basically the lower watermark at the minimum displacement. So our cost graph will be an upside down cost graph, and thus our amplitude must be a negative 6. Now we can find k, and then we also know that t, the period, is equals to 12. We also know that k is equals to 2 times pi times frequency. We can be rewritten as 2 times pi over the period, and since period is 12, we have 2 pi over 12, and then thus k is pi over 6. Now that we got K, we can find C, C being the center of motion. Basically, what we need to do is to take the minimum displacement, 48 meters, and add the magnitude of the amplitude to it. So C is equals to 48 meters plus 6 meters, and then we'll get 54 meters. We have A to be minus 6, we have K to be pi over 6, and we have C to be 54. So our final equation is x equals to minus 6 open bracket, minus 6 cos open bracket pi over 6t close bracket plus 54. And the question has asked us to find the earliest time the ship can enter and the maximum time it can stay in the harbor. According to what was just said, we will have to equate our displacement formula to the time, to 51 meters to find the time when the water level first reaches 51 meters and is last at 51 meters. And if we find out the answer using the CAS calculator, our answer will be t equals to 2 and t equals to 10. Thus, our earliest time will be 7 a.m. plus 2, and thus we get 9 a.m. So from here, we can see that before 9 a.m., the water level will be below 51 meters. And the maximum time the ship can stay in the harbor is 10 minus 2, 8 hours.